The Sun is so massive that it contains 99.8% of all the mass in our solar system, dwarfing every planet, including Earth. Yet Earth's water, covering 71% of its surface, holds the key to life as we know it. Here's a striking thought. If we poured all of Earth's water onto the Sun, it would barely make a ripple. Did you know just how tiny our planet's water is compared to the vastness of the Sun? Let's uncover what really happens in this cosmic showdown. The sheer volume of Earth's water. Earth's water is staggering in scale. About 1.4 billion cubic kilometers of it spread across oceans, rivers, lakes, and underground reservoirs. This vast quantity covers around 71% of our planet's surface, shaping climates, ecosystems, and life itself. But when you compare this to the Sun, the numbers tell a different story. The Sun is a colossal ball of plasma with a volume roughly 1.4 million times greater than Earth's. So even if we could somehow gather every drop of water on Earth and pour it onto the Sun, it would be like adding a single teaspoon to an Olympic-sized swimming pool. This comparison highlights just how immense the Sun truly is. While Earth's water seems endless to us, it's practically negligible on a cosmic scale. Understanding this contrast not only puts our planet's resources into perspective but also sparks curiosity about how such a relatively tiny amount of water would behave in the Sun's extreme environment. This sets the stage for a fascinating exploration of what would really happen if Earth's water met the fiery surface of our nearest star. The Sun's enormous scale. The Sun isn't just big, it's unimaginably massive. When you hear that the Sun's volume is about 1.4 million times that of Earth, it's hard to grasp what that really means. To put it simply, if Earth were the size of a small marble, the Sun would be a gigantic beach ball towering over it. This vast difference in scale means that even the entirety of Earth's water, which feels endless to us, is just a tiny speck compared to the Sun's sheer size. The Sun's enormous volume is made up of scorching hot plasma, a state of matter so extreme it's unlike anything we experience on Earth. This immense size and energy output allow the Sun to sustain nuclear fusion, the process that powers its light and heat. So when thinking about pouring all Earth's water onto the Sun, it's like trying to fill a massive ocean with a single bucket of water. The Sun's colossal scale means that this water would barely make a dent, swallowed instantly by the star's overwhelming mass and energy. This contrast between Earth and the Sun's size sets the stage for understanding why such a dramatic idea, pouring all our planet's water onto the Sun, would have surprisingly little impact on the star itself, even though it would be catastrophic for life here on Earth. What is the Sun made of? The Sun is not just a giant ball of fire, it's a swirling mass of plasma, mostly hydrogen and helium, existing in a state that's completely alien to us. About 74% of the Sun's composition is hydrogen, with helium making up roughly 24%, and the rest are trace elements. This plasma state means the Sun's gases are so hot and energized that electrons are stripped from atoms, creating a soup of charged particles. Unlike the water we're familiar with on Earth, which is liquid and cool, the Sun's surface temperature is around 5,500 degrees Celsius, and its core reaches an astonishing 15 million degrees Celsius. In this environment, water molecules can't survive. They would instantly break apart into hydrogen and oxygen atoms. This extreme heat and energy make the Sun a nuclear fusion reactor, where hydrogen atoms fuse to form helium, releasing immense energy that powers life on Earth. So when thinking about pouring Earth's water onto the Sun, it's important to remember that the Sun isn't a solid surface or a cool body of water. It's a blazing, electrified plasmasphere where water can't exist in any familiar form. This fundamental difference in composition and state of matter explains why Earth's water would be completely transformed the moment it touched the Sun's atmosphere, setting the stage for what happens next in this cosmic experiment. What happens to water near the Sun? Well, water and the Sun are a recipe for instant transformation. The moment any water from Earth approached the Sun, it wouldn't stay liquid for even a fraction of a second. The Sun's surface temperature is about 5,500 degrees Celsius, hot enough to vaporize water instantly. But it doesn't just evaporate like steam from a boiling kettle. The intense heat breaks water molecules apart into their basic elements, hydrogen and oxygen atoms. These atoms then become ionized, meaning they lose electrons and turn into charged particles, blending seamlessly into the Sun's already roiling plasma. This process happens so quickly and violently that the water essentially disappears, losing all its original form. Instead of a splash or steam cloud, the water's atoms become part of the sun's fiery atmosphere, carried away by solar winds or absorbed deeper into the star. This extreme environment ensures that Earth's water would never accumulate or create any visible effect on the sun's surface. So, pouring all of Earth's water onto the sun wouldn't cause a dramatic explosion or change. It would be a silent, instantaneous absorption into the star's blazing furnace, highlighting just how hostile and powerful the sun truly is. Would the water affect the sun's composition? Adding all of Earth's water to the sun might sound like it could change the star's makeup, but in reality, it's barely a drop in the cosmic ocean. The sun's mass is about 330,000 times that of Earth, and its composition is overwhelmingly hydrogen and helium. When water, made of hydrogen and oxygen, arrives, it's such a tiny addition compared to the sun's massive volume that it won't noticeably shift the star's elemental balance. The hydrogen from water would simply blend into the sun's existing hydrogen supply, while the oxygen atoms would be quickly ionized and absorbed into the plasma. This means the fusion reactions that power the sun would continue unaffected, as they rely on hydrogen nuclei colliding under immense pressure and temperature in the core. The sun's immense energy output and gravity dwarf any influence Earth's water could have. So despite the dramatic idea of pouring all our planet's water onto the sun, it wouldn't alter the star's composition or behavior in any meaningful way. This highlights the incredible scale and power of the sun compared to our home planet, emphasizing how small Earth's resources are in the grand scheme of the cosmos. Could the oxygen from water cause any reaction? Oxygen might seem like a wild card when it comes to pouring Earth's water onto the sun, but it wouldn't cause any dramatic fireworks. Once water molecules break apart near the sun, oxygen atoms become ionized, stripped of their electrons, and merge into the sun's plasma environment. This plasma is already a chaotic mix of charged particles, so the oxygen simply becomes part of that turbulent sea. Unlike on Earth, where oxygen supports combustion, the sun's extreme heat and pressure prevent any typical chemical reactions. The oxygen atoms don't ignite or explode. Instead, they're absorbed and dispersed by the sun's immense energy and magnetic fields. This means no sudden bursts or new solar phenomena would arise from the oxygen alone. The sun's fusion process, fueled by hydrogen nuclei, remains untouched by this tiny addition of oxygen. So, while oxygen is essential for life on Earth, in the sun's blazing furnace, it's just another particle swept up in the endless dance of plasma and energy. This shows how different the sun's environment is from anything we experience, turning familiar elements into something entirely alien. What about the sun's energy output? So, what about the sun's energy output? Well, the sun's power actually comes from deep within its core, where nuclear fusion transforms hydrogen into helium, releasing immense energy that lights up our entire solar system. This energy output is so vast that, honestly, adding Earth's entire supply of water on the sun's surface wouldn't cause any noticeable change at all. The fusion process really depends on conditions in the core, temperatures of around 15 million degrees Celsius and crushing pressure, not on what happens at the surface or in the outer layers. Water, once it's vaporized and broken down, just becomes part of the sun's plasma without affecting the core's reactions. The sun's brightness, heat, and energy output remain steady because they're governed by these internal fusion processes, which are, honestly, far beyond the influence of any external material like Earth's water. So, this means that no matter how much water we pour onto the sun, it won't brighten, dim, or flare up in response. Understanding this really helps us appreciate the incredible stability and power of our star, which just keeps shining brightly, totally unaffected by even the most dramatic additions from our tiny planet. Would this water cause solar phenomena? Solar activity like flares and sunspots might seem like they could be influenced by adding something new to the sun's surface, but Earth's water wouldn't trigger any of these phenomena. These solar events are driven by the sun's complex magnetic fields and plasma dynamics deep within its atmosphere, not by external substances. When water reaches the sun, it's instantly vaporized and broken down into atoms that blend into the plasma without disturbing the magnetic forces at play. The sun's magnetic field lines twist and snap due to internal motions and charged particle flows, causing solar flares and sunspots, processes far removed from any material we might add on the surface. So, pouring all of Earth's water onto the sun wouldn't spark new solar storms or alter existing ones. Instead, the water's atoms would simply become part of the sun's vast, turbulent environment, invisible and insignificant against the backdrop of these powerful magnetic phenomena. This highlights just how dynamic and self-contained the sun's activity is, governed by forces and energies far beyond anything Earth can contribute. Could this water create a visible effect? Any hope of seeing a dramatic splash or cloud when pouring Earth's water onto the sun quickly fades under the star's intense conditions. The water wouldn't linger or create visible effects like steam or mist. Instead, it would be instantly vaporized and broken down into individual atoms, which would then be swept into the sun's seething plasma atmosphere. This process happens so rapidly and thoroughly that no splash, plume, or cloud would form to catch the eye. The sun's surface is a roiling sea of charged particles and magnetic fields, where anything foreign is quickly absorbed and dispersed. So, rather than a spectacular visual, the water's atoms quietly vanish into the sun's fiery environment, becoming part of the endless energetic dance that powers our star. This invisibility of Earth's water on the sun's surface underscores just how extreme and overwhelming the sun's environment is, turning something as familiar as water into an unnoticeable drop in a blazing ocean. Earth's water is precious. Earth's water might seem endless to us, but it's a finite treasure that sustains every form of life on our planet. Losing it all to the sun would mean the complete collapse of ecosystems, agriculture, and human civilization. While it's fascinating to imagine pouring all that water into the sun and watching it vanish, the reality is that Earth's water is irreplaceable and vital. This cosmic thought experiment highlights just how precious and unique our planet's resources are in the vastness of space. The sun, with its immense power and size, remains unaffected by such a small addition. But for Earth, water is the foundation of life, climate, and even our future. Protecting and valuing this resource is crucial because, unlike the sun's endless energy, Earth's water is limited and fragile. So while the idea of sending all our water into the sun sparks curiosity and wonder, it ultimately reminds us to cherish and safeguard the life-giving liquid that makes our world so extraordinary. What other cosmic questions or wild ideas do you want to explore next? Let me know. Thanks for exploring this cosmic journey with Space Facts. If you enjoyed uncovering what would happen if all of Earth's water poured onto the sun, don't forget to hit that subscribe button and ring the bell icon so you never miss an out-of-this-world fact. We love hearing your thoughts, so drop a comment below. What other space mysteries should we dive into next? Keep looking up and stay fascinated.